Rules, 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 more rules. Today we're going to talk about the chain rule. And the chain rule is an approach to differentiation of dependent variables y that include more complex combinations of the independent variable, usually represented as x. So we might have something that looks like this, where we have a function y which is equal to x squared plus 1 squared. And this idea of the chain rule is to represent this part of this function y as another function which is a function of x. We just call that h of x. And when we do that, we can kind of simplify the representation of y as just equal to h squared. So we have y is equal to h squared. If we want the derivative of y with respect to h, you all know how to do that. We just use the power rule. And we know the dy dh is equal to 2h. So very straightforward. Now, we really want to know what the derivative of h is with respect to x. And now we know that x squared plus 1, which is, we let x squared plus 1 equal h of x. We know that dh dx is just the derivative of x squared plus 1, so we use our power rule and our sum rule, and we know that this derivative should be equal to 2x. And if we take the product of those two, we have dy dx, it's dy dh, dh dx, the dh's cancel out, right? So we end up with dy dx, which is dy dh, which is this term over here, times dh dx, which is our 2x. So our dy dx then is equal to dy dh, dh dx, we get 4x times x squared plus 1. Okay, so there, after you've done this a few times, you usually recognize that what you're doing is differentiating the function. We often refer to it as differentiating from the outside to the inside. And so if we have a function like, the one we just looked at, where y is equal to x squared plus 1 squared, then we start on the outside, and we know this is, we know we have to handle the terms on the inside of the parentheses here, but we know this is squared. So let's just apply the power rule to this function. So we multiply x squared plus 1 by the exponent 2 and reduce the exponent by 1, so we get 2 times x squared plus 1 to the 1 power. But then we have to multiply that by the derivative of the inside terms, the terms inside the parentheses. When we do that, we take the derivative of 2x squared plus 1, we get 2x. That's not a minus sign, that's just a dash. And so our result is that dy dx is the result of that outside differentiation times the inside differentiation. Get the derivative of the quantity squared viewed from the outside. We get 2x squared plus 1 to the 1 power times the derivative of the inside terms. So now if we apply the chain rule to the differentiation of trig functions, it's the same idea. We know that the derivative of the sine is just going to be the cosine, but we have a complicated argument here. The angle is a function of x, a more complex function of x, 2ax. So we know that the derivative of the sine of theta is equal to the cosine of theta but we have this complex argument here, and we have to note that the derivative of sine of 2ax is not going to be cosine of 2ax. We have to use the chain rule, and sort of going outside to inside, we apply the rule we know for the trig function, but then we have to multiply that by the derivative of the terms inside the parentheses here, this complex angle. So we have y is equal to, just kind of casting this in terms of the way we handle a chain rule, is we let h equal this 2ax, and then we differentiate the sine of h. So we have dy dx is equal to dy dh times dh dx. Well, dy dx then is equal, we know that dy dh is equal to cosine 2ax, or cosine of h. I'm skipping a little bit here, but we've substituted h for 2ax. And then we multiply that times dh dx. In other words, the derivative of 2ax is just 2a. And in the end we get the derivative dy dx is equal to 2a cosine 2ax. So in general, when we're differentiating a function which is a function of another function which is a function of, and so on and so forth, and we have a complex string of interrelationships, then the derivative dy dx is just going to be equal to dy df times df dg times dg dh, and so on. So we have this series of products. These df's cancel out, the dg's cancel out, the dh's cancel out, the dq's cancel out, and we end up with dy dx. So here's a simple example of the chain rule if you're given that, and we're looking at a negative exponent in this case. So if we have y is equal to x squared plus 1 to the minus 1, and we let h equal x squared plus 1, so that we have y is equal to h to the minus 1. And then we just kind of proceed as we normally do. And just using the definition of the chain rule, in this case we have a function of a function. We have dy dh, dh dx. H is equal to x squared plus 1, so we know that that derivative is equal to 2x. The x squared h to the minus 1 is going to be minus h to the minus 2. So we have these two components of the chain rule. Our dy dh is equal to minus h to the minus 2, which we'll substitute back in there. And we find that that's equal to, and our dh dx, which we find is equal to 2x, and then we substitute everything back in, and we find that our dy dx is equal to minus 2x times x squared plus 1 to the minus 2 power. So I kind of left out that this is minus x squared plus 1 to the minus 2 power, but we're just letting h represent that up here and then substituting back in down here. So here's another example. We have y is equal to a plus bx squared to the 3/2 power. So, it's a little bit more complex. We can differentiate from the outside to the inside, or we can let h equal a plus bx squared, so that we'd have h to the 3/2 power. So we have, taking that approach, we let h equal a plus bx squared. We rewrite y as h to the 3/2 power. And then we use that two-factor derivative to evaluate dy dx as dy dh, the derivative of this term here, h to the 3/2 power times dh dx, the derivative of this term. And then again we get dy dx is equal to dy dh times dh dx, and leaving a little bit of work for you, but what you'll get when you fill in some of the steps that I skipped through here, you should get dy dx is equal to 3bx times a plus bx squared. Note, if we do it from the outside to the inside, we have 3/2 times all this, a plus bx squared. So we have 3/2 times a plus bx squared, plus the times the derivative of the inside terms, which is 2bx. So we have 3/2 times 2bx, which gives us the 2's cancel out, so we get 3bx times a plus bx squared to the 1/2. We have to reduce that exponent by 1/2. So kind of a quick review of the chain rule. The next time we will look at the product rule. So if you have any questions, might come back and review this video again. And I did leave some work for you to clarify on your own. So we'll see you next time.